Hello and welcome to another insightful episode of Bona e Kiniso, where we help you realize the truth about and with software testing. I'm your host, Stefan Luckermans, and today, we're diving into some key basics of software testing. We will explore the difference between test stages, test phases, test levels, test types, and test techniques. My lovely spouse, Tracy Luckermans, will be my co-host for the day, commenting and providing examples. Welcome, Tracy, and thank you for helping me with this episode.
Glad to be of assistance, Stefan. Understanding these core concepts is essential for anyone involved in software development, from testers to developers to analysts and project managers. Knowing how these elements fit together will help you better navigate the testing process, improve collaboration, and ensure that software is delivered with the highest possible quality. We have a lot to cover today, so let's start.
First, where does the need to define test phases, levels, types, and techniques come from? We must consider the software development lifecycle when testing software. Testing is not a goal in itself. It is a way, an enabler, or a support for the delivery of software. Within that lifecycle, the first or top layer, we must build a strategy, the second layer, on how testing will support the delivery. That strategy uses tactics, the third layer, to ensure the delivered product has specific quality characteristics. Every tactic will use different methods or combine methods, the fourth layer, to ensure the quality characteristics are guaranteed. Now, how is this accomplished? The first layer, the Software Development Lifecycle, or SDLC, is about test stages or test phases. In software testing, the terms test stages and test phases are often used interchangeably to refer to the significant parts of the software testing lifecycle, or STLC. These stages or phases represent distinct periods in the testing process, and each focuses on achieving specific goals and ensuring the software meets its requirements.
Think of test stages or phases as the significant milestones within the software testing process. Each phase is designed to ensure that a particular set of activities is completed before moving on to the next. This structure allows for testing to be carried out systematically and organized, ensuring that all critical aspects of the software are covered. If well-tuned, a test phase will always be part of a phase of the SDLC.
Here's a possible simple breakdown of some test stages. 1. Test planning. The test planning phase is where everything begins. This phase defines the scope, objectives, and approach for the entire testing process. Teams outline their testing strategies, decide on tools and resources, and determine the schedule. During test planning, the project manager might define which work product to deliver, establish a baseline for risk-based testing, establish the scope by having a high-level product breakdown, and establish which project areas need manual versus automated testing. These are only some of the activities done in the planning phase.
2. Test design. The test design phase is where test cases, scripts, and scenarios are designed based on the requirements of the software. This phase translates the planning phase into actionable items, focusing on creating the necessary tests to verify that the software performs as expected. In this phase, the high-level product breakdown is refined and detailed. Here, the analysts will work on the vertical traceability, the breakdown or refinement of the product. The testers will work on the horizontal traceability, making sure that all requirements are covered by the test design. This and the risk-based approach make a detailed plan to have efficient testing.
3. Test execution. The test execution phase is where the magic happens. In this phase, the design test cases are executed and testers document the results, identifying bugs and issues that arise. This phase directly verifies that the software behaves according to its design specifications.
Stefan, you make it sound easy, but in fact, the test execution is not only about executing test cases. As a tester, you must execute cross-browser tests to verify that the application functions correctly on Chrome, Firefox, and Safari.
4. Test closure. The testing activities are wrapped up and evaluated in the test closure phase. In this phase, teams analyze the results, create final reports, and document lessons learned. The goal is to provide a comprehensive summary of the testing effort and ensure that any remaining issues are tracked. After testing a web application, the team creates a test summary report that lists all the issues encountered, their severity, and whether the software is ready for release. It provides evidence of the testing and evidence of the traceability to make sure all requirements were covered and tested.
Of course, this is only a possible software testing lifecycle. Your organization may already have a software development lifecycle that includes testing. The art is to fit testing in that SDLC. Test stages or phases provide a high-level structure for the testing lifecycle, guiding the software from initial planning to final release and beyond.
The second layer, the strategy layer, is about test levels. While test stages or phases refer to the big picture structure of the testing lifecycle, test levels focus on the different kinds of software being tested. They often reflect the way testing is organized in an organization, and they always fit in the software development lifecycle. Unless the SDLC is disorganized, a test level will always occur within a test phase and a test phase within a phase of the SDLC. Let's assume 4 test levels. 1. Unit testing level. At the unit level, individual components or units of the software are tested in isolation. The goal here is to ensure that each unit functions correctly on its own. A unit test's focus is on verifying that a piece of code works. Basic verification like initialization, the way a screen looks, data formatting, and so on are the subject of unit testing. In Agile, this is the TDD part. 2. Integration testing level. At the integration level, the focus shifts to testing how different units or components work together. Integration tests validate that the interfaces and interactions between components function as expected. An integration test not only verifies if components work together, it also can verify logic. Are the requirements describing the logic of a functionality covered and respected? Of course, integration tests also cover the communication between components, between a front end and a back end, web services, connections to third-party systems, etc. In Agile, this is the BDD part. 3. System testing level. The system level focuses on testing the complete and integrated software system. System testing ensures that the software meets the specified requirements and works as a whole. In an e-commerce platform, system-level testing could involve testing the entire user journey, from browsing products to completing a purchase and receiving a confirmation email. 4. Acceptance testing level. Finally, the acceptance level validates that the software meets the end user's needs and requirements. Acceptance testing is typically the last level of testing before the software is released to the client or the public. In acceptance testing, the client may verify that a CRM system performs all custom functionalities, such as generating reports and managing customer data, according to their business needs. Test levels ensure that software is tested thoroughly from the individual components to the entire system, allowing for a deep, layered evaluation. Again, the provided example is a simplification of what you will have in your organization. The third layer, the quality layer, test types. Moving on to test types, you want the product you are building to have specific quality characteristics. It has to be complete and correct, allow 100 users at the same time, be hacking-proof, and so on. Test types define the specific kinds of tests that are executed to verify these quality objectives. Where test levels never span multiple test phases, the same test type can be used in any test phase or test level. Let's look at some of the most common test types. 1. Functional testing. Functional testing ensures that the software functions according to its specified requirements. This type of testing focuses on verifying the quality characteristics such as functionality, completeness, correctness, and so on. A functional test might check whether the search bar in an online store returns the correct results, correctness, when a user enters a query. It may also verify whether all logic rules are covered, completeness. In the end, we verify functionality is working the way it is supposed to be. 2. Non-functional testing. Non-functional testing evaluates the software's performance, reliability, and usability quality characteristics. This type of testing assesses how the software performs under certain conditions. Non-functional testing might involve testing the performance of a website during a flash sale to ensure that it can handle high traffic without crashing. It may verify that a functionality keeps its integrity even if we use out-of-the-box data. In the end, we verify that functionality is working within certain boundaries. 3. Security testing. Security testing ensures the software is secure and protected from potential threats or vulnerabilities. It includes tests for data integrity, user authentication, and protection against external attacks. It covers the security quality characteristic. Security testing might involve determining whether sensitive data, like credit card information, is properly encrypted and stored. This is often referred to as white hat hacking. Test types allow the testing process to cover all aspects of software quality and are not bound to one particular test phase or test level. The fourth layer, the methods layer, test techniques. Finally, let's discuss test techniques. These are the specific methods or approaches used to design and execute tests. Different test techniques allow testers to systematically cover different test scenarios, identify potential issues, and accomplish the goal of the test type they are executed for. Test techniques tell us how we will do testing. Here are some techniques. 1. Equivalence partitioning. Equivalence partitioning divides input data into different partitions or groups. Each group represents a different condition, and tests are designed to cover each partition. For a form that requires users to enter their age, equivalence partitioning might involve testing various age ranges, for example, under 18, 18 to 65, over 65. 2. Decision table testing. Decision table testing is a software testing technique used to evaluate system behavior based on various input combinations. It involves creating a decision table outlining different test scenarios, their corresponding inputs, conditions, and expected outputs. By systematically representing different decision rules and actions in a tabular format, decision table testing helps testers identify all possible test cases, including edge cases, and ensure that the system responds correctly under different conditions. This method is particularly useful when dealing with complex business logic or systems with multiple combinations of inputs that lead to different outcomes. In a decision table testing example for a login system, the system's behavior is evaluated based on different combinations of username and password inputs. 4 main conditions are considered. 1. Both username and password are correct. In this case, the system grants access as both inputs are valid. 2. The username is incorrect but the password is correct. The system denies access because the username does not match the expected value, even though the password is correct. 3. The username is correct but the password is incorrect. The system denies access because the password is invalid, even though the username is correct. 4. Both the username and password are incorrect. The system denies access since neither input is valid. This process outlines all possible input scenarios for a login system, ensuring that each condition is thoroughly tested to check the system's responses to different combinations of valid and invalid inputs. 3. State transition testing. State transition testing checks how the software behaves as it transitions from one state to another. This is especially useful for systems where the output depends on the current state and the input. In a banking app, state transition testing might verify that a user can successfully transition from an account locked state to an account unlocked state after entering correct security details. Test techniques provide the methods and strategies needed to create comprehensive and effective test cases, ensuring that all scenarios are accounted for. In conclusion, as we've discussed today, test stages, test phases, test levels, test types, and test techniques are all crucial components of the software testing process. Whether you refer to them as stages or phases, these parts form the backbone of the software testing lifecycle, guiding the testing process from planning and design through to execution and closure. Test levels are part of the test strategy, while test types make sure the quality characteristics of the software are covered, and test techniques provide the specific approaches needed to verify that the software meets its functional, non-functional, and security requirements. Thank you for joining us on this episode of Bona Ikiniso. I hope this podcast has provided valuable insights into some testing basics. If you still have questions or want to comment, please send a mail to podcast@face.org. We hope you will join us for our next podcast.